So the Hadoop distributed file system architecture, we mentioned there is this main data node called a NameNode or the main namespace that contains only metadata. By metadata we mean description of the data and not the actual data itself. So it just contains information of what is the file name, what are all the blocks that are part of this file, and where are all the copies of the file in the cluster. And so the client, if it needs to obtain a particular file, it needs all the pieces of the file, and each piece could be anywhere in these machines. So it has to contact the main NameNode and obtain information about the blocks of the file. So the client can read the blocks of a particular node, and it can contact the NameNode to obtain information of which blocks to read from which node. And again, each block is replicated several times. The client also can, for the most part, the way this system is designed is the expectation that most clients will be doing reading. So write once and have many reads, but the client can also write and create a file. And so it creates a file, then that information will get stored into the NameNode and the three copies will be created and replicate that file. So there is a NameNode that is the main node that manages the entire namespace. It maps a file to a set of blocks, and then it maps the block to a particular data node where it will be stored. This name node also it takes care of the replication, so it creates several copies of the files, and it has to do with management of the cluster configuration. So that is a very important function. The types of the data that is storing is the list of all the files, the blocks that are part of these files, and where are the blocks. So a list of data nodes for each block. What could be information about files? The same as you have on your local file system. The name of the file, the owner who created the file, at what time the file was created, when the file was last modified, and what is the size of the file, and all of that. That's part of the attributes of the file. Transaction log, who accessed these files, when they last accessed them, who created them, did anyone delete any of the files, and so a log is kept with all this information. So this is very important function of for the cluster. That's pretty much making all the files in the whole cluster, and we have only one of these name nodes. So what happens if it fails? Does that mean the whole cluster will be dead? What do you think? Any ideas? What if the master node fails?
There's a backup node which comes up. There is a backup node which actually restores the main master.
Okay, very good. We do have one backup for it in case it fails, so that it can take over. And that one backup is not just sitting there doing nothing. It will perform some more functions during that time. The rest of the nodes are called data nodes, and they just store the data. So they contain blocks of particular files. So there is a data node is called a block server, and it stores data on its local file system. and the information about the block. And then the clients will connect to the DataNode to obtain the data from them. DataNode also has a block report. So it does a block report. So periodically it will send a report for its blocks that it has to the master to the NameNode. And this way, if anything changed, the NameNode has to be notified. It also forwards data to other specified data nodes. How do we decide where each block should go? So we do need to keep copies of that. One copy is per node. Each copy is on a different node. So there's one replica on a local node and the other two go somewhere else, usually not even on the same rack. They go into a different rack. And additional replicas can be randomly placed. So how do we choose? We just choose by random. And the clients will read the copy which is closest to them. And that obviously makes sense since the farther they are, the longer it will take to get to them. And so performance will be affected. Another thing is we asked what would happen if the NameNode failed. That's a very good question. What would happen if the DataNode failed? Would we expect that the DataNodes will fail? We are designing this system with expectation that they can fail at any time. So how are we going to recover from that? How do we know that they even died in the first place? Anyone?
Periodic signals.
The data node sends heartbeat to the master node.
Yeah, very good. So the DataNode will just send a message or a signal to the master, to the NameNode, and it sends this signal every 3 seconds. This is called a heartbeat because pretty much like our heartbeats, every few seconds, the data nodes will send their heartbeat to the main node, and if they don't, then the main node knows that they're dead. Their heart is not beating anymore, so they're gone. If the data node fails, then the blocks that are in it are lost, and we will go and look for their copies on the remote racks. So the NameNode detects the data node failures because they no longer send their heartbeat signal, and chooses a new data node for the replicas. Now it has to, when it does that, it is considering which nodes are being used the most at the time. And so it does some load balancing in a sense that it will choose a node that is not that heavily used at the time. So it will balance not only this usage, but also network traffic to those nodes. So if there's too much traffic, if there is some of the network lines have too many packets in them, then this means that they're very slow, and so it will try to choose one that doesn't have that much traffic at the time. We do have some basic error checking for the data. So there is cyclic redundancy check called words, words is used. This is an algorithm for adding redundant parity bits to the data to make sure when the data is received that it's correct, or if there is error, it will detect those errors. and it's possible to correct the errors. So this checksum is used for error checking. The checksum is computed for every 512 bytes, and the data node will store this checksum. When the file is being accessed, the client can obtain this checksum and check for errors. And if the validation fails, then we will go and look for other copies. This basically means that there is corruption on the hard drive, and that the file is corrupt, and there's something wrong with it, and it cannot be read if this checksum doesn't come out right. So if it checksum detects the NameNode failure, it's a single point of failure. We do have this transaction log that's going to store the name nodes when they failed, the directory on the local file system, and the directory on the remote file system. So we will keep this log in several places in case the log itself gets lost. As we mentioned, the NameNode keeps a list of all data nodes where the pieces of the file are stored. So when the client needs a file, it will get a list of the data nodes of where to look for the pieces of the file. The client will write a block to the first data node, and the first data node forwards the data to the next node in the pipeline. And by pipeline, we mean the path of block 1, block 2, block 3, block 4, until we get to all the blocks through which nodes do we need to go through on the network. So that's the pipeline. When all the replicas are written, the client moves on to write the next block in the file. So every time we have a block, then we will create copies